Good morning. I'm so glad you're here. So today we are working on section 5.1, which is graph linear equations. This is continuing on in that big packet for graphing that we have. Okay, so to start, we have just a reminder that slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So for part one, we're going to determine the slope and the y-intercept. And then we're going to use those two things to graph our equation. So what's different about today is everything isn't already in slope-intercept form for us. So we have to do that. So we have the y plus 3x equals negative 2. So we want to keep the y by itself and move over everything else to get it into that form. So what I'm going to do is just do a minus 3x from both sides. So I have y equals negative 3x minus 2. I would make sure that you put the x first. Some people try to write y equals negative 2 minus 3x, and that's not quite in slope-intercept form. Okay, so we really want it into y equals mx plus b. And then this way we can see that the slope is negative 3. The y-intercept is at 0, negative 2. So to graph this, I go to 0, negative 2, because that's my y-intercept, and I plot that point. And then I count from that point using my slope to find additional points. So I'm going to go up 1, 2, 3, over 1, because it's rise over run. I'm going to go to the left, because in the end, reading it left to right, just like how I read a sentence, I want it to go downhill because it's a negative slope. I'm going to stick one more point on there. I'm going to go up 1, 2, 3, over 1, and grab my straight edge and connect them up. Put the arrows on the ends, and that one is done. Go ahead and try the next one. Okay, so first, get it into slope-intercept form. Identify what the slope is, what the y-intercept is. Go ahead and graph it. Come back when you're ready. All right, so hopefully that wasn't too bad. It was pretty close. It was almost into slope-intercept form, right? All you had to do was just divide every single piece by 3, and then you get y equals negative 4/3 x plus 2. Slope is negative 4 over 3. Y-intercept is 0, 2. So you go to 0, 2, plot that point, and then just count rise over run to get that slope of negative 4/3. Very cool. Go ahead and turn the page. And there are 3 on that page. I want you to hit pause, and I want you to try to do all 3 of them, okay? And then I'll go ahead and scroll and show you the answers here. So hit pause, give all 3 of them a try. Okay, so for number 3, we had to do a couple steps here. First, we had to subtract the 6x, and then we're left with that negative 8y. A lot of people forget that negative, okay? But that stays with the 8. So we have to divide every single piece by that negative 8. Getting y equals a 6 over 8x, because we had negative 6 over negative 8 is a positive 6/8. And then minus 2, because 16 over that negative 8 is negative 2. We reduce and find out that our slope is 3 over 4. Y-intercept is 0, negative 2. So we go ahead and plot that at negative 2 and use the slope to find additional points. Very good. The next one, if you aren't quite ready, hit pause again. Otherwise, here it is. Getting it into slope-intercept form, we have to move both that 15x, so a minus 15x from both sides, and adding a 36 to both sides. We go ahead and divide everything by 12, getting y equals a negative 5/4 x plus 3. Plot the y-intercept, use the slope, and get that line. Okay, the next one, y plus 5 equals 0. This one looks a little bit different. It's just y equals negative 5. And if you remember from the other day, that y, anytime you get y equals a constant, it's going to be a horizontal line. So you can either use that knowledge that you already have to complete this problem, or an alternative is, if you wanted to, you could think of it as y equals, because we don't have any x's, 0x minus 5. Plotting that y-intercept of negative 5 and knowing that the slope is 0. So it's just that horizontal line. All right, very cool. Go ahead and turn the page. So another way to graph an equation is by finding the intercepts. and use those as your 2 points needed to make the line, because you just need 2 points to make a line, right? So here I have a little graph, and I'm asking you to identify which one do you think is A, which one do you think is the y-intercept where it crosses the y-axis at the point 0, y. Okay, that's going to be this one up top here. Whoops, this guy is A, and our x-intercept is down here, so there's B, where it crosses the x-axis at x, 0. So how to find the intercepts when given an equation? The y-intercept is 0, y, right? That's what we just said up above. So we replace the x with 0. So you can see, let me try to draw a line here and show you. Every time you're finding that y-intercept, x is 0. If you're going to go and find the x-intercept, where x is 0, we replace y with 0. So you can see every single time y is 0. Okay, so we're going to use that as our new method of graphing. So part 2 says find the x-intercept and the y-intercept, and then graph the equation. Okay, so I always write it out. Let me do that. X-intercept 2x plus, because remember, if we're finding the x-intercept, we replace y with 0. So instead of y, I'm going to write 0. So I have 2x plus 4 times 0 is 20. So 2x plus 4 times 0 is 0 equals 20. And then we can divide both sides by 2, and we get x equals 10. This means that our x-intercept is 10, 0. And if you want, we can go ahead and plot it right now. Let's see. On my x, I have it out to 10, so 10, 0 is here. Okay, and then for the y-intercept, replace x with 0. So I have 2 times 0 plus 4y equals 20. 2 times 0 is 0, so I have 4y equals 20. Divide to get that y by itself, and I'm getting y equals 5. So that means that the y-intercept is at 0, 5. So I'll go to 5. 2, 3, 4, 5. There it is. So now I have the 2 points that I need to connect my dots. All right, so I can make my equation, I can graph it. Get my arrows on there, and that one is done. Okay, the next one, it has fractions. Go ahead and give it a try. See what you can do. Go ahead and find that x-intercept by replacing y with 0. Find the y-intercept by replacing x with 0. Try to plot those 2 points and see what you get. Okay, hit pause. Press play when you're ready. Okay, so we're going to find the x-intercept. We go to the y, we put in 0. So I have 1/4 x minus 1/2 times 0, that's just 0, equals -1. To get rid of that fraction, we're going to go ahead and multiply by the reciprocal. So I'm going to times both sides by 4/1. Or you can just think of it just as times 4, because it's the same thing. When we do that, you can see the 4's will cancel out, leaving you with just x equals a -4. So it means our x-intercept is at -4, 0, which on my graph is about there. For my y-intercept, replacing x with 0, so I have 1/4 times 0 minus 1/2 y equals -1. 1/4 times 0 is 0, so I have a minus 1/2 y equals -1. multiply by the reciprocal. At the same time, I'm going to also multiply it by the negative so that I get a positive y, because I don't want to know what negative y is. So I'm going to multiply by a negative 2 over 1. So multiply by negative 2. And we do that because the negative and negative will make it be a positive. The 2's cancel out, so all I have left on this side is just a y equals 2. So the y-intercept is 0, 2. We plot that point, connect our dots, and we have our equation graphed. All right, the next one has some decimals. It's not too bad. You can use a calculator. Go ahead and try it. Go ahead and graph number 8 by finding the x-intercept, and then by finding the y-intercept, plot those 2 points, hit play when you're ready to check in. All right, so I've got it here. I replaced the y with 0, getting 8.1x equals 14.2. Had to get the x by itself, so I divided. Remember that squiggly equals just means approximately, so I just rounded it to 1.75. And I went to go and graph it. I know that 1.75 is 1 3/4, so I just estimated on my graph. I just did the best that I could. On the second one, I ended up with approximately 3.64. And I mean, if you got roughly around the 3.5 on your graph, then that's totally fine, okay? Because we aren't computers, we're human. So as long as you tried your best to get to about 3.64, that's awesome. Okay. Now, if you turn the page, I have problem number 9 has comparing 2 graphing techniques. So I want you to try this whole page on your own, okay? So for part A, it says to graph the equation 4x plus 5y equals 20 by finding the slope and the y-intercept. Go ahead and try that. And then for part B, it says to graph that same equation by finding both intercepts, okay? So again, part A is the old way, the way that we've been practicing already, slope and y-intercept. And part B is the new way where you plug in y for 0 for the x-intercept and x for 0 for the y-intercept. Go ahead and try the whole page. Press play when you're ready. Okay, so by doing it the first way, subtract 4x from both sides, divide everything by 5. You use your y-intercept of 0, 4 to start. You plot that point, and then you use your slope of negative 4/5 to find that additional point. Okay, so in the end, your picture should look like that. For the second one, both intercepts method, do we have the same picture, first of all? We do. It doesn't matter if your big dots ended up somewhere else. Okay, just in the end, if your line is in the same area, then you're okay. So for the x-intercept, 5, 0, y-intercept, 0, 4. And then at the bottom, it says compare your graphs. So we just did that. We saw they're the same. And then which method do you prefer? And totally your opinion. Most of my students in this particular one, they like the intercepts method just because it was so clean that the zeros just wiped it out and it was just a simple little division. Okay, but it's totally up to you, whatever you prefer. Now the next page asks you to do the same thing. Okay, so you're going to have a problem. It's graph y equals 2x minus 1 by finding the slope and y-intercept. Okay, and then for part B, go ahead and graph it again by finding the intercepts by plugging in 0 for y and then 0 for x and graph it. Hopefully you get the same picture. Okay, give that a try. Do that whole page and come back when you're ready. So for this first part, super easy, right? Because you didn't have to do anything. It's already in slope-intercept form. So the slope is 2/5, the y-intercept's at -1. Go to -1, plot that y-intercept, start there, use your slope to find an additional point, and you're done. Part B, though. Man, that finding an x-intercept, that gets a little bit messy, right? It's doable, but it's messy. You plug in y equals 0. Have to get that x by itself, so I added 1 to both sides. Want to get rid of that fraction, attach the x, so I multiplied by the reciprocal. Okay, which means that these 5s are going to cancel out, and then these 2s are going to cancel out. So I'm left with 5 halves equals x. 5 halves, you could reduce that down to 2 1/2, or you could punch that into your calculator and get 5 divided by 2 is 2.5. So when you go to 2.5 on the x-axis and plot that point. The y-intercept isn't bad because you just plug in 0 for x, you get y equals -1. So you plot 0, -1, connect your dots, and did we get the same graph? Let me look. Yep, you can see, here's what I mean, is you can see this second point here is different, but in the end you can see that the graph is actually the same, right? Like how on this bottom one it's crossing at 3. If you look up in my top one at 3, it's crossing as well. So that is the same graph, even though we had different big points, okay? Awesome, almost done here. And this one, which method do you prefer? This one is pretty standard. Nobody picks the fraction way, just because nobody likes fractions. Poor fractions. So this one, if you do though, awesome. If that's your preferred method, way to go. Depends on your opinion. Most people prefer the slope and y-intercept method for this particular type just because we didn't have to do anything. It was already in that right form. So finally, in general, which types of linear equations do you prefer to graph by using the slope and y-intercept? And which types do you prefer to graph by finding the intercepts? So I put just kind of, I mean, it totally depends on the particular problem, but in general, if you have messy decimals or fractions, the intercepts is usually pretty convenient. And pretty much for everything else, just the standard traditional slope y-intercept is pretty solid. Okay, it works pretty good. And that will wrap up today. I hope you have an amazing rest of your day. Fantastic job.